I've been down the rabbit hole and I've been thinking about how the future will look like, I guess. So based on a single assumption that AI will improve slightly, we're in a world where delegating an AI is, I guess, delegating an AI to the maximum efficiency is the skill, not having the ideas, or maybe having the ideas, but not having the intellect, I guess. That's not the that's not the skill anymore. It will be the same as a game of chess, I guess, where if you win at chess, you get paid, and everything is allowed to be used. So you're a big disadvantage if you don't use like a chess AI help guide or model. But this is the world, right? We have access to these tools, and what would that mean? How do we use these tools to the maximum efficiency? And I've been playing with this idea of what doing science might look like in the future. And this is one way of doing it, I guess. So it's based on, I guess, Claude Code. So I will demonstrate here me writing a science article. Testing for, let's see here. Springs. What will we do? I made some dummy data here. Let's physics. Let's try to find K. So we have some experiment we've done, collected data. Now we are trying to first estimate K and then write a science article about K. This is a big project, and for people that are learning physics, this takes like a week, or maybe not a week, but of like continuous work. But you work on this quite a lot, both from the programming perspective and from writing the science article. I'm going to try to finish it in under 5 minutes now. That's my goal. So I'm going to spin up an instance of code. And I'm going to multitask here. So write a script that will take in data from Spring CSV that should calculate K, the Spring coefficient. 2, using types, create a science article for me about this experiment and finding the Spring coefficient. You should use modular code, making one file for the abstract, one for conclusion, etc. One for conclusion, etc. What more do I want? Let's find a types scientific paper. So your school will maybe provide one of these templates. I'm just going to use a random one for now. Let's use this one. use this template. I'm gonna plan ask questions, clarifying questions. Let's see here. Run the Python code. What are things? So this is not a fun future. I forgot to say that. You're not solving problems anymore. The problem you're trying to solve now is how to gain maximum output, and that should be the mental challenge. I don't know how that would look, but that's at least a challenge for humans to solve. Now that we don't have the technical challenges anymore. Okay, let's see if the types will soon arrive. The types code. So types is it's basically LaTeX. The mass. Yeah. Use my name. I'll provide. Let's use anonymous. Comprehensive. Generate plots. Submit answers. I don't know where the types. I guess there's a bit types file for the extension to show. But when Claude is starting to generate the types, we will see basically a continuously updating display of the ready PDF science article with the correct formulas and everything automatically being written. So, Claude to fetch this. Yes. I guess I'm in plan mode, so that's maybe why. I guess I'll accept edits. So this is the future Sam Altman. Are you happy now? Yeah, this is not fun. I must say, this is maybe the future. At least this may be the future of work. It might not be the future of students and learning. This is probably not a very good way to learn anything. But it's probably a very, very, very good way of doing work. And doing, I guess, work you know how... I guess work you know what to expect the outcome to be, or what the correct result is. Claude is grinding, holy shit. I can, in the meantime, show here the Claude MD. Claude likes, and basically any AI model really likes LaTeX. So I need to preface to use types, some syntax to make sure it uses the correct syntax. Types is a modular language, so you can include parts into the file. You'll see this later. But you can also make functions and include functions, which is very nice. So instead of having to write out the entire function, you can define the functions in a lib file, and then basically do like, I guess, like a Spring coefficient with parameters k and x. So you just type maybe like Spring parentheses kx, and then you will get force. So it will display it and then calculate it for you. So yeah, you have like a calculator in LaTeX, which is, or types rather, which is pretty cool. Project structure, that's pretty good. And build commands found like this. Also, after first draft, I'm gonna make a Git. This is definitely, or maybe not definitely, but it's probably a very good tool in the future. I've been thinking. It's not that useful anymore to know like stacks or frameworks or coding languages maybe. But having a version control and mastering that version control, so you're able to abstract parts of the code and what needs to be done in a safe way and then merge them correctly, is probably still going to be a very great tool now with AIs. So yeah, I think Git has come to stay. We'll see that later. Okay, now Claude has been starting to write the parts. If we go into main here, we can go types preview. I'm guessing since the results has not yet been written, it won't show. But this is basically a live updating page displaying the documentation or the science article. And then we can go into introduction here, for example. Introduction. You should probably not include titles. We'll talk about that later, maybe. So some titles, small titles. They have not been using the functions. They have written each function down instead. But you can see this reads very well. It's very easy to read. You don't need to read the PDF directly, as you have to do in LaTeX. But for example, this is very nice because you would have like an bibliography, which is automatically synced as well. So everything gets taken care of in a very structured way, and now with version control, we will have it in a very safe and organized way. And let's see, results is made, and there we go. Science article with plots made. Let's see, there's the figures. Yep. Here we have the figures from our sample data. And there we go. Science article with plots. Let's see what the conclusion is. Conclusion. I don't know why it doesn't let me zoom in. That's annoying. I guess we can make a new chat here and then do types compile main type and read the PDF instead. Okay, here's our science article. Conclusion. Where the data spring constant 3.99 Newton meters. Okay, I don't actually know what the spring constant to expect, or like a good spring constant, so I should probably figure that out. But the period and the, I don't know about the angular frequency, damping coefficient. Yeah, I should probably check what like a expected spring constant would be. But you can see like the tables are nicely formatted, automatically made. The plots are made, and yeah, you need to read through this and make sure it's correct. But it's a lot easier to read and critique than to create. And for learning, you definitely don't want to do this because the creating part is the learning part. But I've created a science article that's probably pretty close to perfect. I guess we'll see someday if someone reads this, if this is good or bad. But yeah, this looks good. Sprinkles. Zero. Yeah, different approaches to estimate angular frequency. Again, I don't know what values to expect here, so I don't know. Even the data was just randomly generated, so I don't know. index. I don't know what this is. I haven't not seen this one before. I guess this is like a keywords type thing. I have the formulas, the derivation. Yeah, no, this is like a, as far as I can see, pretty perfect science article. So yeah, 5 minutes. All the human had to do was collect the data. All the human had to do was doing the boring part, unfortunately. Hopefully, in another universe, we flip this around, you know? Letting the human do the fun part and the AI collecting the data. But yeah, I don't know what would be better. This is a great workflow. So yeah, now you're like git add, git commit, first draft. I don't have a pushed repo, so I'm not gonna push anything. And then we can maybe go like git branch. I guess it's maybe M. I'm not sure. Git branch new the abstract. Yeah. And then Claude rewrite this abstract for clarity. It's a bit too long now. That's maybe a contradiction, but we'll see. So now you can make changes and hopefully like merge them in a good way. I guess you like see where this is going, so I'm pre-finished, but yeah, I think this might be a good guess to where science is going. I don't like it, but that might be